Hello and welcome to my YouTube channel, This is Romani Online Mathematics. If you know you have not subscribed, subscribe and share to your colleagues. If you're also a new time person in this channel, please try to subscribe. Here we teach mathematics and you should learn more here. All right, now let's start with introduction. And the topic is introductory analysis. And under the introductory analysis, you are just going to deal with numbers, natural numbers. You're going to prove natural numbers and all stuffs. Now, when it comes to the introductory analysis, we have a topic called PMI. Full meaning is Principle of Mathematical Induction. Principle of Mathematical Induction. Principle of mathematical induction. What do you mean by principle of mathematical induction? Principle of mathematical induction simply means that it's a technique that we use to prove a mathematical statement, whether it's true or not. Is that okay? It's true for all natural numbers. So now that's what you're going to do. For you to prove mathematical induction, there are 3 steps to follow. 1, the first step is the basic step. That's why you say that when n equals 1. So you put n equals 1 into the equation, both the left and the right of the equation, to see whether they are equal. 2, we call it the assumption stage. That's why you say that n equals k. So at this place, you are assuming that n equals k, then you also substitute into the equation. And the last one is the induction stage. That is when n equals k plus 1. You also put it there to also check if, yes, indeed, both the left hand side and right hand side is equal. So let's look at an example. Right now, the example will be like this. Prove by PMI that this is true for all natural numbers. So you want to prove by the principle of mathematical induction that this is true. And for you to do, I said the basic step is that first you say that let n equals 1. What do you mean by let n equals 1? You see, we have n at the left, n at the right. So he said that let's consider the right hand side, the left hand side first. That is, if I put 1 here, I will get n to be 1. Then let's consider the right hand side. If I put n here to be half 1, 1 plus 1. This will give us half 1, but half of 1 is still half. 1 plus 1 is 2. So that will give half of 2 is 1. Are we seeing that? So it tells you that the left hand side is equal to the right hand side. This is true. Is that okay? So you proceed to the assumption stage. So now for the assumption stage, we say that you should let n to be equals to k. So let's substitute 1 plus 2 plus 3 plus dot 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 plus. Now here becomes k equals half of k bracket open k plus 1. Let's name this one equation 1. Then we also go to the induction stage. Is that okay? So for the induction stage, we have let n equals k plus 1. So you substitute. You're going to have, I'm going to substitute here, whereby I see n, I'll put k plus 1 there. Have 1 plus 2 plus 3 plus. Now, what happened here is that first I'll repeat when n equals k first, which will give me k here, before I will proceed to add k plus 1. So you should take note of this side. It's like I'm counting 1 to 3. So from, you see, if I add 1 to this, I'll get 2. 1 to this, I'll get 3. The next one, I'll add 1 to this, that will give me what? 4. So this one is already there. Then I'm adding 1 to this, that will give me k plus 1. So you don't ignore this and go straight to this one. No. And this is equals to, so wherever I see k here, I put n here, I put k plus 1. Then I'm going to have half of bracket open k plus 1. That is for this n. Another bracket open, k plus 1. That's for this one, then plus 1. Okay, let me expand this one. I have 1 plus, but before I will expand this. Let me name this one equation 2. Let me name it like that. What is going to happen here is that I'm going to put equation 1 into equation 2. So we say that put equation 1 into equation 2. Is that okay? What is happening is from 1, 2, 3 up to the k here is the same thing here. So I'm going to replace the whole of this from here to here by this. Is that okay? So I'm going to have half k bracket open k plus 1, right? Then this is here plus k plus 1. So from here to here is half k plus 1, which is equals to half k plus 1 k plus 2, because 1 plus 1 is 2. Now at this point, this is where you check whether the left hand side is equals to the right hand side. Once you're able to check that, then we say that the induction, or it is true for all real numbers. I mean all natural numbers. Is that okay? So let's see. It depends on, you can decide to prove this place, the left hand side, to look like the right hand side. Once you prove here for it to look like this, then you are done. Because since this one is equal to this, then inductions, it is true for all natural numbers. So let's see. So I'm taking the left hand side to prove. Here, if I find LCM, you see that I will get k plus 1 plus 2 multiplied by k plus 1, all divided by 2. Is that okay? I'm proving this to see if I will get this. Remember that if I expand this, I'm going to have, I don't want to bring all over 2. I can still write this one as half into a big bracket like this. They are the same thing. So half, I'm expanding this, I'll get k squared plus, oh, I don't even need to expand this. The inside one are the same, so I'll write one of them, which is k plus 1. Then I'll pick the outside, like you are solving a quadratic equation or you factorize, you get this, right? And realize that this is equals to half of k plus 1, k plus 2. Is that okay? So you conclude, therefore, this statement, you know that this one I can also write it as summation I equals 1 to n, I equals half n plus 1, like this. Is the same thing. So we say that this statement is true. So this is equals to this is true for all natural numbers. Is that okay? If you see this, don't be confused. This one means that this sign means summation, because sigma summation. So starting from 1, I is equals to 1. So we are starting from 1 to infinity. That's the end. So you could see that 1 starting from 1, 2, 3. We are summing it up to infinity. So it's the same thing as this. Is that okay? Now let's look at another example. Yeah, now let's look at example 2. Prove by PMI that for n greater than or equals to 1, equals for this equation, this is a mathematical statement, to prove that this is true for all natural numbers. So let's prove this. First, when we say that you let n equals 1, then you substitute. So when n is 1, you're going to have 1 squared. Okay, which will give us 1. That's for the left hand side. Now let's look at the right hand side. When n equals 1, what happened? to be 1 bracket open 1 plus 1, 2 multiplied by 1 plus 1, all divided by 6. So 1 plus 1 is 2, right? So you have 2 times 2 and 2 plus 1, 3, all divided by 6, which will give you 6 over 6, which is 1. Is that okay? So that one, you could say that the left hand side is equals the right hand side. So normally we say that the induction is anchored always. The statement here is anchored. So now let's move on to the second assumption stage. The assumption states that n should be equal to what? K. We assume that. So if you assume that, it means that if I take 1 squared plus 2 squared plus 3 squared plus n squared. So now our n is now k squared. Should give us k bracket open k plus 1, 2k plus 1. And all this is divided by 6. So I'm going to name this one equation 1. Then the next one 2. You should say that that's induction state k plus what? 1. So what happened here is that I'm going to have 1 squared plus 2 squared plus 3 squared plus k squared. I say you repeat this before you move on to the k plus 1 squared, which is equals to, when I come here, I'm going to have k plus 1 bracket open k plus 1. Remember plus 1 here again. Then another bracket open k plus 2k plus 1. Now this 2k, 2 bracket open k plus 1 plus 1, like this. Remember this one is divided by what? 6. So this one should be named as equation 2. So you're going to put equation 1 into equation 2. So you're going to have 2 squared plus 3 squared. Sorry, equation 1 into equation 2. So from here up to this place is equals to that. So which is here up to here. So I'm going to have k plus k bracket open k plus 1, 2k plus 1. All this is dividing by what? 6. Remember we have this one here already, which is k plus 1 all squared is equals to, this is going to give us k plus 1, k plus 2, or 1 plus 1, that is 2, 2k plus 3, 2, 1, 2 plus 1, 3. And all this is divided by 6. So what I'm going to do here is I'm going to prove this for it to look like this, so that I can say that it is true for all natural numbers. So let's prove this one. First, I find the LCM of this. So I'm doing the left hand side. If I find the LCM, remember I'm going to have k bracket open k plus 1, 2k plus 1 plus 6 bracket open k plus 1 squared, all divided by 6, right? Let me send it. Let me do it here. So I'm continuing this. I'm just proving this to see if it will be equal to that. You can also prove this to see if it will be like this. So here, I have k plus 1 here. I have k plus 1 here, so I can factorize that one out. If I do that, I'll have k plus 1 out. So here, 11 with only k here, multiplied by this 2k. So k multiplied by 2k plus 1. Then here I have 6 brackets open. This is k plus 1 square, so 1 is out, leaving k plus 1. And all this is divided by 6. You shouldn't forget that. It's divided by 6. No, for Now for this one, let me expand what is in the brackets to see if I can get this. I'm doing it up here. So we have k plus 1 outside. Then this one, if I expand this, I'm going to have 2k squared. K times 2k, that is 2k squared. Plus k plus k. Then here will be 6k plus 6. And all this is divided by 6. Now, k plus 6k is 7k. So I'm going to have k plus 1, 2k squared plus 7k plus 6. Now, this is a quadratic. If I simplify this quadratic, I'll get, sorry, remember this is over 6. I'll get k plus 1, and then I'll get k plus 2, and I'll get 2k plus 3. And remember, all this is divided by 6. So look, this is equals to this. So you conclude, therefore, the statement is true for all, since the left hand side is equals to the right hand side. The statement is true for all natural numbers. Again, this one can be written as the summation, which is like this: I equals 1, I squared to n equals then this one, n plus 1 to n plus 1, all divided by 6. So you see that there's a square. It means that if I put 1 squared, I'll get 1. 2 squared, that is 2 squared, which is 4. Like that. So infinity n squared. Is that okay? Thank you very much for watching.